If you're using Supabase in your FlutterFlow project, there is a core fundamental that you absolutely must use. By the end of this video, you'll understand why this concept is not just non-negotiable for security in your application, but it's also a super convenient feature that makes the process of using your database so much easier and enjoyable. That fundamental is, of course, row-level security. It's your primary means of locking down your Supabase database. It gives you full control over what the user is allowed to view and manipulate in terms of data, and it gets as fine-grained and specific as you want it to be. In this crash course video, I'll be covering the basics of RLS. Note this isn't a deep dive into the subject, but rather the goal is to give you an understanding of what RLS is for, how to write some basic policies, and be sure that your app is locked down and secure. I've got an app here running with Supabase Auth. It's going to be a habit tracking app. So I have this list of habits here. And users can create habits and get reminders about them and stuff like that. So at the moment, I've got 2 habits in my database. One is for meditation. The other one is for remembering to drink water. In my Supabase table, I've got these 2 entries. There's a name field. There is a user ID field, which is linked by a foreign key to my authentication table. And I also have 2 users in this authentication table. So actually one of these users owns one of the rows in the habits table and the other user owns the other row. Now, bear in mind that with RLS turned off, the database isn't just public to read, but it's public to write and delete. I could be anywhere in the world, but all I have to do is get a copy of the app, grab the public URL that goes out with every request the app sends to Supabase, and also the anon key, which is also totally public. This information is trivial for any app user to get a hold of. With RLS turned off, I can run a simple query in a terminal like this. This is the curl command. It's just a terminal client for making HTTP requests. Like, for example, I could curl google.com and I would get the HTML page back from the Google website itself. You can, of course, also run curl on an API, and instead of receiving HTML, the idea is that you would receive JSON, which can then be interpreted by your application. So here I've got curl, and then this is the Supabase URL. It's REST version 1, which takes us to the API, and it's the habits table. This API key is the anon key. As I said, it's completely accessible to anyone. And if I just run this command, I actually get all of the data from my database. Here's the drink water field. Here's the meditation row. This just spits out everything. And bear in mind, I don't even need an account to do this. RLS is off and I can just have this data and I can have all of it. But it's not just reads and data theft. With RLS off, I can actually do a patch as well. That's an update request. So I can just target the Supabase API again. And then I can do something like ID is greater than 0. And that means that because they're integers and they're auto-incrementing, that's actually going to target every single entry in the table. I've set a variable for the anon key just to make it clearer. And this JSON type is just a header that specifies that I want JSON. This D is for data. And then I can set the name field to anything I want. You've been pawned is like an old silly hacker thing from the 90s where you've been pawned means you've been hacked. It's a play on you've been owned. And so right now my Supabase database looks like this, where we have the name meditation and drink water. If I run this thing with RLS off and then come back to my Supabase dashboard, do a refresh. Now the data in every row. And if you had a million rows, it would still ruin all of the data in here in one command. If that happens, your database is totally screwed. All your data is gone. Your app is broken. Sensitive details are leaked. Your whole business could get taken down in one command from an attacker. This isn't even really hacking. Hacking implies bypassing security and breaking in. A table with RLS off is more like leaving the front door open. Hopefully you're sufficiently scared, so let's turn on RLS. Great. And I'll just set meditation back to where it was, and also drinking water. Okay, so we've turned it on. So what happens if I try the read command again? Yeah, nothing. No errors even. That's good, but it also means that literally no one can get to the data now. You want some data to be available to certain users. So let's create a basic policy. This one can be a select policy, and that means that only reads and nothing else. We'll name this policy something descriptive. Anyone can read anything sounds good to me. And within the policy itself, I'm just going to write true. So this using tag actually evaluates to a Boolean. And the Boolean essentially suggests, yes, for each individual row, this policy is met, it is true, and so I will return the data. What we're doing here is we're saying only for select, not for creates, not for updates, not for deletes. Only for select, we're going to allow everything. So I'll save that policy. Okay, so now if I try the read again, it will give me all of the rows. However, if I try the update policy again, then in this case, it's going to reject it and it's not going to change any of my data. Okay, we're a bit more secure, but obviously we can do better. So let's edit this policy. And this time we'll set it so that anyone who has an account with the app can read the data, because right now it's public. You don't even need to have an account. You don't need to be registered to read all the data. So we'll switch the policy to this: authenticated users can read data. And this time, instead of public, we'll use authenticated. Authenticated is a role that gets embedded into a JWT authorization token. And so we'll save that one. And now let's see what happens when we try to do the read operation. Again, we get nothing. Okay, so my policy is set up. And if I am an authenticated user, the question is, how do I prove that to Supabase? This is where the tokens come in. Now, in my application, I have actually logged in with Supabase authentication. And so now what FlutterFlow has done is it's attached the correct token. Instead of just attaching the API key to the authorization bearer, which it was doing before I was logged in, now it's actually giving me the real token. And you can see this in any API request that gets sent to Supabase. You just have to be here in the network tab and you need to go to headers. So I'm going to copy this token. And in actual fact, I can go to a website called jwt.io and paste the token in here. And this website will decode it for me on the front end. So this is all the information that exists within that token. It knows the URL of the Supabase. It knows my own sub. That's my actual user ID from my auth users table. This is a timestamp for expiry of the token. And the expiry is an hour from now. And it knows about me. It knows my email. It knows whether my email is verified. And then it's got this thing here, role authenticated. And role authenticated is a Postgres role. So actually when I went to set up the policy here and I said authenticated, that's what it's doing. It's reading the target role from the JWT token itself. Cool, so now that the authenticated role is set up, I can append the token itself to the curl command. And that just goes like header, authorization, and its bearer. And then I just paste in the token. And when I run that, I can once again get all of the data from all of the tables. Okay, we're really getting somewhere with RLS now. But still, we haven't personalized the RLS policy. So actually, just because I'm authenticated, that means that regardless of what user I am, I can still get all of the data from any other user. This is where RLS gets super powerful and it starts to stand out against what Firestore rules can do. Because actually, RLS will filter for us. Instead of using true, what I can do is I can say auth.uid parentheses is equal to user ID. The user ID is the actual column on the habits table. And auth.uid is the user ID that is pulled out of the token itself. Because as I showed you within the payload, the ID of the user exists. If I do this, then RLS will automatically filter the data and only return the entries that satisfy this condition. What that practically means is that if I send my token into this request, I'm only going to get back my own data. So I, the logged in user with ID here, only gets the entry drinking water because that's the ID that was embedded in the token. Okay, so users can now read their own data. We're going to want to do the same things for updating and for deleting. So let's do update. I'll create a policy and I'll go for update instead of select. This one will be called users can update their own data. We will of course want to be authenticated. And then I'm going to go ahead here and do the same thing. Auth UID is equal to user ID. And with that, I should now be able to update my own data. Now, there's one more other thing that I want to point out about this update operation, and this is the reason that earlier on I created another column called updates permitted. Because actually you can put extra checks for extra security on things like update operations. There may come times where you want users to be update certain data, but not update other data in the same table. One of the ways that you can do that is by having a column like updates permitted, and I've defaulted this to false. So even though my update will work right now, maybe I want to set that extra constraint. So I'm going to use a check expression and I'm going to say updates permitted needs to be equal to true. And so if I do it that way, then theoretically the data here in the table is not going to satisfy that. So let's try that out. So now I'll do another update request. That's another patch to the Supabase URL. This time I'm going to target ID is equal to 4. So that's this one here, the drink water row in the habits table. Again, I'll attach the anon key, I'll put the headers in, and I also made this variable token just to clear things up a little bit. But this again is the bearer token that I took from FlutterFlow, and I'll try to change the name. And this is what happens when using the with check expression. It actually gives me a message this time, and it says it's violating row level security for the table habits. And then the cool thing is that that policy is set now at the table level. But if I were to change this value to true and then go ahead and do the request again, then when I run this command again, I'll see in Supabase that the name was updated. Now you would do similar policies for delete as well as create. In the case of create, you actually would definitely want to use authenticated user, but unlike with the other policies, you would just give it true, because you can't check the user ID of a row that doesn't exist yet. And then with delete, you would of course be authenticated again, but in this case, you would again use the auth UID is equal to user ID. And that'll make sure that only people with user ID matching their token can delete their own records. And if this clause is universally going to be applied, you can actually give it to all as well and save some time. But it's generally better to build these policies individually. And it doesn't stop there. You can actually start writing some pretty complex SQL statements inside of an RLS policy. You can start assigning roles and you can start assigning conditions. It's a whole language, so it's really, really flexible. So make sure you start playing around with the AI and try to learn as much as you can about what RLS is capable of doing. And then finally, let's look at our app. For this user, they got stuck still with this name was updated entry. That's the update that I made from the command line. But note how for this user, that's all that's showing up. Now, if I log out of this account and then I log in as the other account, then now I should be able to see meditation, the other row in the Supabase table. And that's the one that's assigned to me. That's the one that I will have created, been able to update and been able to delete. So now all of our data is siloed in such a way that users own their own data, and that's all thanks to row level security in Supabase.